Good morning and welcome to our online webinar to learn more about InFarm and artificial intelligent cost-reducing methods for weed control. My name is Lorinda Otto and I'm the Relationship Lead for Southern Queensland Landscapes and the Roma Node Drought Innovation Hub Manager, proudly introducing the amazing work InFarm is doing in our region. InFarm is an agricultural artificial intelligence company focused on delivering groundbreaking technology to farmers. They use state-of-the-art AI and advanced technology developed tools to help producers become more profitable and efficient in their own land. InFarm's vision is acceleration agriculture innovation for global benefit, and the mission is developing integrating digital tools with on-farm assets to unlock financial and ecological sustainability for global agriculture. Jerome Leray is the founder and managing director of InFarm. He is committed to delivering solutions to farmers that increase productivity, resilience, and sustainability. With a B-Commerce and postgraduate qualifications in mineral exploration and geoscience, Jerome founded InFarm in early 2017 off the back of a highly successful aerial surveying and remote sensing business. Jerome is a recognised industry leader, having been awarded the Agricultural Minister's Emerging Leader Award in 2020, as well as representing Australia in the Entrepreneurship World Cup. For Jerome's contributions to technology and agriculture, he received a Queensland Community Achievement Award that led InFarm to be awarded Australian Food and Agribusiness of the Year 2019. Congratulations, Jerome. It is with great pleasure that I introduce the man of the hour to you all and look forward to what today's learning will bring each of us.
So I've been doing this for since about 2017, and we've really been focusing in on how do we detect and spot spray weeds across the country. And so we've been working with some of the biggest companies in the world to develop the technology solutions to be able to deploy these big data and AI solutions. So that includes working with Dell to create a supercomputer so we can bypass the internet, as well as working with some of the biggest ag chem companies that are leveraging our technology to detect weeds and spot spray them. We've also been recognised internationally as one of the top 1,000 ESG solutions. So looking at how do we combat climate change and how do we become more sustainable, but do that in a way that's profitable and not antagonistic to production. Now, we're pretty proud of this achievement because at the time we were two guys in a shed in Gundawindi, and we went up against some of the largest multinational companies to get this recognition, companies in the energy, mobility, and building and construction space. So we're really proud of that, and it's something that's core to our heart. So in terms of today, what I'd like to do is maybe give you a bit of a background around AI, what it means, how it works. I'm also going to start to discuss what we call perception, which is the next evolution of AI that's coming along, and then how we actually leverage perception to be able to spot spray weeds. And I'm a bit of a practical person, so I like to kind of talk about these things by providing a bit of an example on how we do it and on an example of how this technology is being deployed, specifically this time in roadside, but this could be in pasture environments. It could be in gas corridors. It could be basically in any wild environment where we're looking to manage and spot spray weeds. So what is artificial intelligence? Now, you might have heard of machine learning, deep learning, artificial intelligence. They're all call it the same thing. But the way that we leverage AI is that we look at billions of different variables, and each of them is trying to define a specific feature. So, for example, with weeds, it's like, where are potentially the green pixels? How do those pixels join together? And then we ask the computer to learn which of those features are the most important to be able to detect that plant species amongst the rest. And so really what it is looking at all those billions of variables and just figuring out which are the right combinations of those features to be able to get that positive detection. And that's all it really is. Now, you hear that AI is going to take over the world and it's going to doom civilization. I don't necessarily agree with that. And that's because the AI is what we call domain specific. So it gets trained on specific types of data sets. And then if you go and change that domain, it's actually not good at generalizing or figuring out the generalization. And so this is a nice slide that really illustrates this point. So this AI was trained on detecting chihuahuas from other dog species, and then the AI was fed some images of some baked goods, and it started to detect some chihuahuas there. Now, we as humans can generalize that, and it's quite easy for us to differentiate. And looking at those cupcakes and cookies, we understand why it could have thought that that these might be chihuahuas. And so once again, that AI, once it's been trained in that domain, it's really good at that domain, but it can't then go and generalize into other environments. Now, the next iteration is what we call perception. And so that's really about figuring out how do we take those disparate sensor types, whether they be from satellite, planes, drones, mounted on booms on tractors or looking underground, and then how do we actually derive those insights from AI, from other types of analysis to then drive the action. And so perception is that whole entire package, from being able to make sense of the world through those sensors, interpret it, and then be able to take that action. And that's really what our whole entire business is about. And specifically, we're looking at, in this scenario, how we use that technology to spot spray weeds. Now, the reason why we would like to spot spray weeds is, one, it's a massive herbicide and chemical reduction, but it also means that we can start to get a bit more prescriptive around how to manage that species, those species at those growth stages. And we can get much more prescriptive and truly manage the incursion of those weeds across the landscape. And so it's really about how do we only spray where the weeds are, with the chemistry or the biology that's actually going to kill them and manage them. And so that brings us to the project that we did up in the Maranoa Council. And like to thank our partners in the Maranoa Regional Council and also the Department of Transport and Main Roads, or TMR, for basically being really responsive and proactive to test this technology. And so what we did is we went to the council and proposed that there might be a way to spot spray and use artificial intelligence to spot spray Parthenium weeds on those roadsides. And so the way, or the process that we go through to train these AIs and to develop these systems is pretty simple. First, we go across the paddock, we capture the images. We then use those images and provide training samples to the AI. So we say, is this the weed? Yes or no? And we then train the AI. And then we go ahead and validate. So taking it out into the paddock or onto the roadside and going, okay, did we spray the weed? Yes, no. This is where the AI is weak. And then we bring that data back into the training set so the AI continuously gets better. And so as part of that data collection, what we did is we spent 2 weeks in that Maranoa region, and we collected over 400,000 images in a target site. Of that, we only labelled 41,000 images, and we roughly got 4,447 samples of images of Parthenium weed. And so when you consider that, most of the area did not contain Parthenium, and so we really tried to identify those areas where there was a target-rich environment to increase the quantity of plants that the AI would see. And so from that, we looked at how do we collect the data across different environments. So the AI, because it's so domain specific, if it's always, say for example, being done in all the data is in where there's red soil as a background, or there's it's sunny or it's overcast, what we need to do is collect those images in a variety of different environments. So when the plant is healthy, when the plant is dead, when there is high competition from the pasture, or when there's low pasture competition, where there's dirt, rocks, different soil types, and different types of plants, and then also looking at those different weather environments, so sunny, overcast, raining. And so what we want to do is be able to build that library worth of data so the AI is good at generalizing and detecting the plant across those different scenarios. Now, obviously, in this project, we only collected data across 2 weeks. It was quite dry, and so we didn't have any examples of Partheniums when it was really healthy and in its growth stage. But it was really about evaluating the technology and how it might actually be deployed for that roadside management of Parthenium. And then the last thing that we did is we actually GPS tagged all of the images that we took. So we know exactly where all those Parthenium plants are, and that provides a fair bit of optionality in terms of looking at pre-emergent sprays and those types of things to manage the weed seed bank in the future. So once we collected those images, what we did is we basically did what we call it Tinder for weeds. Is Parthenium in this image? Yes or no? And we basically swipe left, swipe right, depending on if there are the weeds or not in those images. And here's some examples of what Parthenium looked like at the time, and then some examples of some images where there was no Parthenium. And so we basically just labelled the data there. From there, we trained the AI and we went out into the paddock. And so this is what the machine looks like. It's basically got 2 camera systems that were controlling, each camera system was controlling 2 nozzles. And depending on where the weed was in that image, it would turn on the left nozzle or the right nozzle to spot spray those weeds and log the GPS location. Now, the reason why we put it on a quad bike is just the easiest way to go and collect the data and transport it around to get that variation in the data sets. But this could be fitted to a side-by-side, onto the back of a ute, onto the back of a tractor for agricultural purposes. We've deployed it on an 18-metre system to go ahead and spot spray weeds in grazing, in cropping environments. So it gives you a bit of an idea of the versatility of that system, but it's basically camera, detection, solenoid, and it's really leveraging artificial intelligence in the back end. Now I've got a bit of a video that shows you how it operates. So what we went and did is picked up a Parthenium plant. I know that's not what you meant to do, but it shows how the technology works. And so what we do is we go ahead and wave it underneath there, and you can see the nozzle triggering. And when he brings it across to the other side, it triggers the other nozzle. So very, very simple process from an operational point of view. Once you've loaded the AI in that camera system, it will go ahead, deploy, detect, and spray. This is what it looked like in the paddock. So we were just trying to, or on the roadside. So you can see the environment, highly bumpy, quite complex. It is quite dry, so detecting the Parthenium plant is not necessarily easy. But as you're going along, it's literally detecting and spot spraying those plants. And so from an operations point of view, if you're a bit more on the roadside, you'd be going up and down, and you could just basically set the A/B lines and track it like you do in a farming operation. Once again, here's the detection of all those Parthenium plants. So what that means, and what everyone got a bit excited about, was from a reporting point of view, where are the weed locations? Looking at this from an evolution point of view, is the management reducing the Parthenium plants and seed bank? We can also start to track how it's propagating, or we are actually starting to win the battle around there. One of the hard things to do is, if people are doing a good job, you shouldn't be able to see Parthenium plants. And so this is a way of verifying and validating that. So every GPS point can literally have a photo associated with that shows that the weed was actually sprayed at this particular point in time. So it's really good from a management and tracking point of view. So once again, the process was capture the data, train the AI, and then we validate and deploy the system. And that same process can be deployed for any type of weed. It's a process that we have down pat, and we went from never having seen Parthenium to being able to spot spray it in that environment in 2 weeks. And we're working on trying to do that in a couple of days. And so we'd really be keen to talk or work with companies, with nations, and with SQ Landscapes to develop AI systems that graziers, roadside management, and commercial operators might be able to use to get on top of the weeds. And so I suppose my question to you is, what weed would you target if you had this technology? And just like to open it up to any questions. How did you want to do questions, Lorinda?
Yep, I was just going to say thank you, Jerome.
Did you want to put people in the chat, or did we want to give people the ability to unmute themselves and ask the question directly?
They're more than welcome to unmute at this stage. I have got a couple of questions in the meeting chat.
Yeah, sure.
From Brett. Brett Smith has asked, are you still looking to do any trials in the cropping paddocks, perhaps Mexican poppy? And then
sure. So we would look at doing some trials and some deployments in the cropping environment. We've done some already. Always looking to do more. It's just a matter of mobilizing the team, collecting that data, training it, and then deploying it. One of the things with Mexican poppy, we're finding that it has a pretty strong correlation to soil types. And so if you can actually map your soils, you could potentially put some pre-em type herbicides down and actually stop the Mexican poppy from germinating if you get the right pre-ems based on that soil type. So I thought I might just flag that, Brett. But we, you know, once they get away, you want to go and spray them. Definitely be interested in doing some trials in cropping paddocks for that.
Probably. Sorry, Jerome. But probably specifically, we find we're mainly grazing these days, but grazing crops. So a lot of the oats country, I think, because traditionally you're not putting much in-crop herbicides, or it's bare at a time of year when Mexican poppy get away. But the challenge of finding as we go to more multi-species, obviously you're narrowing what you can use, you know, particularly pre-emergence, and oats is quite sensitive to a lot of chemicals anyway. And sorry, my other point, just that you can't, you sort of, if you got broadleaf, you know, multi-species crops, you can't do too much in-crop control anyway. So that's why I just thought, if it, you know, Mexican poppy is probably the only one we sort of have issues with, mainly because the sheep don't eat it compared to the other weeds. So that's probably, just a real scenario that I thought something like this might be pretty useful. You know, so.
The other questions, like in a cropping environment, especially in a multi-species environment, like if you were to go and put in some herbicide that you know that are going to knock around some of the other broadleaf weeds, is it acceptable to have 0.5% or 1% of the paddock that's relatively bare if you've managed the Mexican poppy? Because you're spot spraying it, you're not blanketing the whole area. You might have reduction in production in those little zones that you spot spray, but you have gotten on top of the Mexican poppy problem and reduced its seed bank. And so is that something that from a commercial and operational point of view, is that acceptable? I don't know. That's a question.
Oh, yeah, well, probably.
Wouldn't
concern us probably too much.
Yeah.
Or you'd be using a broadleaf. You know, you still have the oats there. You still have cereal. You know, you'd still have the oats. Just using some basic chemical like 2,4-D.
Yeah.
You know, you're not going to knock the oats totally. Might slow it down, but won't knock it around. So.
And then maybe can outcompete it, and then.
Yeah, that's right. And I think it'd be just a couple of years. If we had 2 or 3 years, you could just get and use a bit of this technology where you get to the point you may not need it, or you just get on top of it. Or in combination with other tactics. Yeah, so.
I suppose the question is, if you were able to go into a paddock and say, I'm only going to go and target Mexican poppy, would that be valuable? And then basically, how do we leverage the AI and develop? Make sure that it's developed to be able to go and detect and spot spray.
Yeah, well, that's well, it's probably at the point that, and there's always family politics in it, but we're not going to, at the point there's paddocks you're not putting any multi-species into because we can't control the poppy, or it's perceived the poppy will get out of control. So we're sort of, you're stopping going, you're stopping trying to move forward because of one weed that, a bit of this technology could get on top of and get to a point it's not a concern. So.
Yeah.
Thank you, Brett. The next question was around Hudson pear.
Oh, Hudson pear. So listen, Hudson pear is definitely one that's maybe a little bit trickier just because it's a little bit larger in terms of its size. So if we were bringing a boom over the top of it, firstly, you probably have to go and drive over the top of it or drive near it, and you might help propagate it that way. So I'm not sure that the ground-based system would be the best way about doing that. I think if you were able to go and detect the plants using, say, for example, a drone at high res, so flying the drone quite low, you could detect all the locations and then go and spray it. But I believe there's some work being done in New South Wales where they're looking at different biological control agents. And although it's not a liquid herbicide, so maybe not quite easier to dispense, you could have a spot dropping system that could be deployed aerially. At the end of the day, all we're doing is what we could do is use the AI to detect and locate each of the plants and then have a different management strategy to be able to do it. But I'm not sure that the ground-based system, like we showed for that Parthenium, is the right way to deal with that plant. Having said that, if you disagree and you want to do a project, we definitely would look at it. I'm just trying to think of, from a practical point of view, how do we deploy this technology? I think maybe looking at aerially detecting Hudson pear and then managing it from the air, or being able to provide the GPS locations to drop those biologicals might be a better way of going about that. I don't know who asked that question, but happy to have that a bit more of a discussion there to make sure that I've answered their question.
It's Nick here. I'm the person there with no name on the symbol. Yeah, I deal with a lot of Parthenium throughout the Injune to Rolleston area.
Yeah.
I work in the gas industry. Yeah, I was wondering, that'd be, if that sort of thing on a drone would be like, we've used drones at times for control. Yeah, we're looking at different ways that we can control the weed on all our leases and access roads and all that sort of thing. A lot of it at the moment's been aerial and spot spraying, but yeah, we're open to all sorts of things. Yeah.
When you say spot spraying, is that like knapsack and spot spraying with a human? Yeah. Right, cool.
Yeah, ute unit with a 100-meter hose on it, sort of thing.
Yeah. So listen, that's where I reckon this detection system, where you're spot spraying and detecting it, like detecting it live and spot spraying and getting the GPS location, I think has a fair bit of application there, especially on those access ways. It becomes a little bit harder in, say, grazing environments when you've got trees to have big booms. And so you've got to have something that's a little bit more mobile. So something that might be, 4 to 6 meters behind a side-by-side is maybe one of the better options to be able to deploy this technology. But as I said, the Parthenium component, we've got to get a bit more data around when it's green and vibrant and in that growing phase to make the AI a bit more robust in that domain. But that's something that we'd be definitely keen to work with the gas industry if they're interested. One of the things is, once we've developed the AI and it's good in general, we can then go and deploy that and deliver that to anyone that has the system. And so if you're helping us develop that for your roadside access, we can then go and help push that to any of the graziers or farmers that might have Parthenium on their access ways. And so it helps kind of combat that weed. Your comment around using drones to detect Parthenium, I think that could potentially be a bit challenging, and that comes down to the resolution of the image. So we need to be quite close to the ground, I think, to be able to detect the Parthenium plant and get high resolution image. And the way to think about it is, if you can't look at that image and detect that Parthenium plant, the AI is not going to be able to do it, because we need the human to be able to detect and train it. Something like Hudson pear is a bigger plant, and so that's where the aerial method works. But I would, if I was a betting man, I would say that detecting Parthenium using drones would be significantly harder Is that something that you found, or can you see the Parthenium in those drone images quite clearly?
No, not the drone images. You can't really detect it. Yeah,
It's hard.
yeah.
Yeah, and so that's where I think the ground-based systems might be a little bit better, because they're closer to the ground and they have a higher resolution, or relative resolution to the drone images.
Yeah, our biggest thing is driving in the areas where it is. It's sort of we try to prevent any of that from happening.
Yeah.
Okay, the next question is from Jody regarding Verbinia and GRT.
That GRT, yeah. We haven't done anything in GRT. We're being told that we need to do that really quite quickly, and I've had plenty of bribes with cartons coming to my place to go and do GRT. But definitely keen to put a project together with NRM groups or anyone else in terms of who's looking at that GRT. We'd love to do something there and see whether or not this technology can be deployed in that environment and for that weed.
Okay, and then there was another question from David, just asking if there are any weeds similar to pasture or crops or native plants that actually confuse the AI.
Yeah, really great question. Really great question. So we had a native, I can't remember what it was called, that was quite similar to the Parthenium plant. And I think Parthenium is actually native as well. Or it might be another Pimalia that's native. And it, the only way that we get around that is having samples of the Parthenium and, say, for example, that native. And the more data we have of both of those, then we can train the AI. This is the one that we want to spray. This is not the one that we want to spray. And so it's a question about obtaining enough data and then making sure that we have the features that are highly differentiatable. And so what we can basically make that up by having more data of the problem, the weed, and then the native that we might want to keep. And so it's just a function of collecting that data. Does that answer your question?
Absolutely. Thank you. Thank you so much, Jerome. So at this stage, it seems like it's a quite human intensive training of the AI, both taking the pictures and then, like you said, tindering it to say, yeah, yes or no.
Yeah.
And then in a similar vein, also saying, don't touch this, don't touch this. So very, very interesting. Thank you.
Yeah, we're trying to, you mentioned it was quite intensive. Right now, we've got to mobilise to site, collect that data, tinder for weeds, and press train. We're trying to make that a bit more scalable. Like, we don't know every domain and in every environment, and there's a lot of experts that do. And so how do we give you the ability to put the system into collect mode, go and collect your own images, and then just you do the tinder for weeds, and then press train the AI, and it basically is automated that way.
That's very clever. So sort of public scientists, sort of crowdsourcing data.
Yeah. Public scientists or companies that don't want to wait for us to go and do it, and they can just take control of themselves and go and do it themselves. That's something that we're trying to develop. It takes a bit of time, and we've got to focus on the business and growing the business. But that's definitely something that's on our roadmap, and it's actually something that's like, we want to enable people to be able to solve their own problems using the technology, and so that's something that we're pretty keen to continue. So if you wanted to go and detect where all these native pastures are compared to spot spraying it, we could theoretically know exactly what plants, native or not, where they are in the paddock, and look at a time series of that. So if you're looking at, say, for example, biological credits or something like that, not biological credits, biodiversity credits, you could actually get species distribution over time if you trained your own AI to do that, for example. Does that make a bit of sense, David?
Absolutely. And so your guys' AI is proprietary. Are you using GPT or anything else, or you're training and building your own?
we're building our own pipeline, but yes.
And so we contribute to that AI. Yeah. Okay.
Hope that answers your question.
It does. Thank you.
Thank you, David. I have another question from Brad Olixon around lovegrass. So he's the gentleman that asked about the Hudson pear as well.
Cool. Did you want to give me a bit more context around the lovegrass, as in you want to detect and spot spray it? Is that the goal? Or I know it can be a bit of a problem, well, especially in northern New South Wales, but also, well, it's just going everywhere. Is that the goal or the purpose? So who was the gentleman that said lovegrass? Bradley.
Brad.
If you're asking if we've done any work on lovegrass, the answer is no. But we could definitely build one of the aims of that we would like to do is get our team to come in to a region and maybe target a couple of different ones. So we've done Parthenium, lovegrass could be another one, GRT could be another one. So if we set our team up, for 2 months worth of work, and their sole purpose is to basically go and collect the data, train the AI for that specific weed, and then go to the next region, collect some more images of those different weeds to get that distribution. That's something that we'd be really keen to do. So really looking at how do we package a couple of these weeds, maybe in southeast Queensland, and then see which ones are potential candidates for this ground-based spot spraying system. That's something we'd be interested to do. And I can't see why lovegrass wouldn't be one of those ones that we add to the list, because I can see it on the roadsides. As I drive around the countryside. Are there any more questions?
Just having a quick look in the chat line. It doesn't look like there's anything else that's come through.
I'd just have one more. We work with some agronomists and soil scientists that are doing similar work with soil mapping, not just digging a pit, but GPSing and trying to establish where there's sort of weak points in the paddock. That might be something that could. So would weeds pop up where certain soil conditions are occurring as well? Would there be benefit in collaborating on, because these data sets are going to get huge. I think there'll be silos of businesses working with huge data sets and huge AIs that are mapping the same areas, and at some point in the future they might correlate.
So I mean, we're definitely finding correlation with soil type and which plants are growing there. I'm not sure that that's a new in any way, shape or form. But then that starts to get into how do you preemptively manage those, knowing that those are potentially the higher targets for these weeds. And then if you were able to spot spray, how does that information kind of fold into your management strategy? And so we'd definitely be keen to explore different ways with researchers on how that might work. Your comment about this, there's a lot of data. To give you a bit of an idea of just how much data we generate about 3/4 of the Netflix library worth of data from one of our sensors per day.
Wow.
And that gets processed, no cloud, no internet, straight at the farm gate. And so that's part of a lot of the technology that we've developed in the back end, is how do we actually deal with all of that data to train these AI systems. And so
absolutely. And that's also siloed to protect you from other AIs using that data. And also the connection to the internet, the dependence, because we have horrible internet as all the country does. And so what you want to do is have a local LAN that has the AI on farm and just talk throughout the paddocks.
So there's definitely a security point of view, like you mentioned. The other one is the fact that no matter how good Elon's internet is, he's not going to be able to keep up with that quantity of data.
Yeah, with that data. It's got to be
so the reality is we don't actually have a choice. And so we've had to develop those systems, and that's why we've partnered with the likes of Dell, who created, you know, effectively a supercomputer that can operate in hotter environments a couple of years ago, and we've been testing that and deploying that in Gundawindi.
Oh, that's excellent. Thank you. That answers my question.
Jerome, I've just got Joe Morn with his hand up, and then I have another question after that, please.
Fantastic.
Yeah, just a bit of a concern about doing it with a vehicle. You're going over Parthenium. How do you make sure you're not spreading it?
Yeah, this is probably the one concern that I have specifically with Parthenium, and there'll be other weeds that are like that. The way that I would like to see that is we probably know when Parthenium is going to set seed and flower and then set seed. So managing the plant before that happens is probably the right way of going about that, so you're not spreading the seed bank. When we did it, which was quite dry, was probably not the right environment to be doing it. And looking at it when it's more in its growth stage before it goes reproductive is probably the way that you would do that, Joe.
Oh yeah, thank you.
Do you agree, disagree?
No, it's just a general concern when you've got vehicles in a weedy area about spreading. But like you say, if you can get the timing to minimise it, that would be a good help.
Yeah.
And I have a question from Brock McDonald regarding Parramatta grass and fireweed, please.
No, we haven't done either of those, Parramatta grass or fireweed. I must admit I don't know enough about those, so I don't even know what they look like, how they reproduce, whether they're good candidates for the aerial side or whether they're better candidates for the vehicle-mounted system. I'm sorry, I can't provide you any more detail on that, but if they're weeds that are in the area, we could definitely develop a trial and see whether or not they're good candidates. Did you maybe want to provide a little bit more context around those two weeds?
Yeah, hi Jeremy. It seems to be mainly a coastal issue. I mean, I'm over in Toowoomba at the moment, and fireweed is certainly the new Parthenium that's taking off over here. It's more of a winter weed.
Mm-hmm.
But yes, it spreads and puts up a very large seed bank very quickly, so it becomes a very long-term problem, same as what Parthenium does. Parramatta grass is making a slow march north, and it's another one of your choking grasses. It looks like a small version of your rat's tail grass, so it's certainly going to be an issue coming forward.
Okay.
And then you've got your cactuses, I suppose. I'm just trying to think of the species name at the moment. Long, cylindrical-looking fellow with 4-inch spikes. He's
Harisia.
That's the one. That's the one. Yes, wonderful, nasty little fellow to have.
So I know that there's been some stuff done with spot spraying Harisia cactus specifically. It's obviously quite an alien-looking plant. So from an AI point of view, highly differentiatable. And so that's definitely a really prime candidate. We also did some work with Microsoft on trying to detect it from the air. It can definitely be done in dry or drought times. It becomes extremely easy to be able to do that, but it becomes much harder when you are wet, just because it just gets overcrowded and the AI can't quite differentiate between the grasses and the Harisia cactus because it gets overcrowded. And so, yes, it's a candidate to be done by air, but only during dry times. But definitely from a spot spraying point of view on the ground, that can definitely be done. The one caveat is make sure you put have some hard tires, because they will puncture them, but there's ways to manage those as you go over them.
Thanks, Jeremy.
Anybody have another question? Okay, so just due to the technical issues I was having in the beginning, I do apologize that my introduction to Jerome wasn't very successful. There's a wonderful bio that I would love to circulate to the members online. But before I do that, we should have done this in the beginning, but could we just do a whip around the room just to say who's in the room, what your titles are, and how Jerome can share his expertise going forward. I certainly enjoyed learning a bit more about the perception, the data collection for domain-specific areas. And look, training the AI wouldn't be easy in the terrain that he covers. But it's good to know that, to validate and deploy in as little as a few days to 2 weeks is amazing news for us looking, to grow new ways of eradicating or minimizing weeds in our regions. I certainly will be taking up some further information around GRT, and you got me quite inspired to look at that Parramatta grass and firewood. Looks like, Brock. I've never seen it myself. So yeah, looking forward to going forward with the questions that you guys raised today, and hopefully we can work something out in our regions to benefit everyone. So just on my screen, if we can have a look. Brock, I've got you first up, if you wouldn't mind just saying who you are, where you're from. And again, I do apologise that this is at the end of our session. I still don't have a camera, so, oh gosh, next time, hopefully my technology won't let me down. So there you go, Brock, the floor is yours.
Hi guys, I'm William Brock McDonald. I'm with Growcom. I'm based out of Toowoomba. I deliver the farm business resilience planning to link growers and producers to drought resilience funding to try and kickstart capacity projects on farm. So yeah, things like water, dams, putting in new bores, water banking with tanks, various things like that. Hay storage to a degree in grazing operations and various other things. So if you've got a question, feel free to ask it. We'll endeavour to find an answer and endeavour to try and link you to either grants or loan structures to help on the farm. And, weeds is a significant management issue, and particularly in drought as we lose ground cover and we start having issues with dry soil, lack of moisture profiles. Weeds being our premier pioneer plant become incredibly invasive as soon as we do get rain. So the management coming into a drought and coming out of a drought of weeds is significantly important. So, and that's me. So feel free to contact me if you're looking at doing some major infrastructure. Try and link you to at least 25% of grant funding for drought resilience programs.
Thank you, Brock. Next up, I've got Gavin Johansson. Gavin, would you like to say a few words?
Sorry, Lorinda. It's Gavin Johansson from Tackling Regional Adversity Through Integrated Care. We're Queensland Health. Basically, we partner with Southern Queensland Landscapes, Department of Agriculture, Connect Ag, anyone that's in the agricultural industry. And we're a mental health-based program, but we actually do health promotion as well, do speaking, and go out on farm with anyone that's actually doing some work on farm. So I'm just really interested. I come from a rural background as well, so I'm quite interested in what you had to say and what's happening within industry. So thanks.
Thank you for joining us. I've got Brett coming up next on my screen. Brett Smith.
Yeah, my name's Brett. I work for Elders most of the time, but I have a family farm I'm still involved with between Westmar and St George, which is predominantly merino sheep these days, and we're sort of gradually phasing out the farming. But yeah, always interested in some of this technology, and specifically around Mexican poppy in with other broadleaf plants. Yeah, so thank you.
Thank you, Brett. David? you like to say a few words?
Hi, Jerome. Thank you for your time today. I'm a software engineer. I do based in Inverell, so in a farming community, and just very interested in this technology and how it's applicable to our regional areas. And weeds is a great one to be taking on. And there's, I think, a lot of, as you would expect, a lot of potential for your business. So I was just interested in the practical applications.
Thank you, David. Jodie, would you like to go next?
Sure. Hello, I'm Jodie. I work for the Department of Agriculture and Fisheries in Queensland. I'm based in Gympie. My particular interest in your presentation, Jerome, was that we would like to encourage people to implement more perennial legume systems into their grazing businesses. However, particularly as Brock mentioned, in areas where there is fireweed, people are reluctant to invest in those things just because, it's easier to apply a broad-scale, broad-leaf herbicide as opposed to targeted spot spraying. So I think that would definitely be one way of getting around it. And it's similarly for implementing or trying to sow improved pastures where there's GRT. I see that your technology would have a great involvement in that space. So really, I just came along today to be nosy.
Love it. Okay, so the next one is Joe. Hey, Joe. Nice to see that you logged in today. Thank you.
Yeah, I'm just started with TAFE, and next year we'll be running agriculture programs, and I was just keen to get to the cutting edge of weed control.
Excellent. Andy, would you like to say a few words, please?
Yeah, Andy from Coleman's Nursery down in Lockyer Valley. So we're in the intensive horticulture space, but there's probably plenty of AI sort of tech for the greenhouse industry, but just very interested in what might be happening locally or where we can start using some imagery and things for what we do.
Excellent.
I'd encourage you, if you're already taking images, just doing simple things like what's in this image and just describing it in a text box or something like that. That's something that could be highly valuable in the future for you. So if you're already taking images, just kind of trying enriching it with what's in that image could be something to look at, Andy.
Yep, nothing yet, but we're hoping to.
Thank you. Is Nick still online with us?
Yep, can you hear me?
Cool. Yes, I can. Thank you. Sorry, you just dropped off my screen for a second.
Oh, yeah. I'm with Santos. I look after the vegetation management and invasive weed sort of control. And yeah, we're always looking at different ways of controlling our different measures we can put in place for controlling the Parthenium. It's probably it's our big thing that we do struggle with a lot because our work areas are prone to large amounts of Parthenium, and the Hericea cactus is another one that we're actually working on at the moment, getting it under control. But yeah, we just thought this would be good to turn in today and see what this is all about.
Thanks a lot. One of the things that I did mention, like obviously we've got to develop these AI systems, right? And what we've done with some of our, or more like the commercial partners, what we've done is deployed the system or the solution, or made that AI available as, say, for example, it could be the Santos AI for Parthenium or for Hericea cactus, and then that system becomes available to producers to be able to manage that. And so there's a bit of a branding PR opportunity there, as well as the actual management, detection, location of those for internal operations. And so I thought I might take the second and maybe give you a bit more of a direct pitch there, but it's something that we'd be keen to explore if that's something that might be in the interest of Santos there.
Yeah, because it's like we cover a large area. Like we're looking Roma, and our fields go all the way to Ralston, so it's a
massive area.
Massive area, yeah.
Okay, thank you. And last but not least, I've got my colleague Brad Ollickson. If you'd like to say a few words, Brad.
Yeah, I hope everyone can hear me. Can anyone hear me at all?
Yep.
Oh, yep. Yeah, great. Yeah, so working as a delivery project officer for Southern Queensland Landscapes, been across quite a lot of programs since I started here about 18 months ago. Brigalow, Brigo threatened ecological communities, weeds, pests, the grazing futures, livestock business resilience, all that sort of stuff. What else have I been across? I've been on the Northern Basin fencing program, and yes, and across the ag Murray-Darling in relation to weed and pest as well. And in all of those circles, there's these weeds that come up and grasses and all the rest of it. You know, when we're out there doing L-cats and veg cats, we see a lot of it. Yeah, so I'm interested to be in this space and listen to what's going on. We do have our mapping people, and we have Paul Webb working in the AI space as well, trying to recognise riparian zones for fencing and other types of work. I just see that, yes, you're right in terms of that. How that AI goes, I just had visions as you were talking about it also starting to pick up the structure on the types of grasses as it looks at it. There's many different ways it could probably compare. And I was looking at a drawing so that it sees seed types and ends and fringes, you know, any of these types of things that hang off grass, because it's so hard to detect and decipher between grasses, even by eye and as a human being walking along, breaking them off and comparing them sometimes. But I imagine into the future we will go, I was starting to see things like X-ray vision and drawings comparing, and then I thought, well, maybe even genetic, you know, smelling or working it out from all these types of how it could be pulled in. So I'll just let the imagination run wild there for a while on different techniques to add into the AI space. But yeah, it's lovely to talk to everyone and hear everyone's opinion and zones of work, and always pick up something and learn something from each one. Thanks very much, everybody.
Okay, so I'll just have a closing question. You sure there's no more questions for Jerome while we're lucky enough to have him?
I've provided my details, so Lorinda, if there's anyone that has burning questions after, we can circulate that, and people can get in contact with me if they have any questions that pop up into their head or their imagination goes wild. Like Brad, we definitely don't do smelling AIs yet, so you're ahead of the curve there.
Yeah, a bit of the old science research breaking through from resources when I was in a bunch of scientists there in the labs everywhere, and we had all sorts of machines coming down to smell and detect different things, from, you know, pig smelling devices to devices deployed out on dams, and yeah, so really wrapped up in that area. So yeah, I just let them, like you said, the imagination run into genetics and all the rest of it, but it may be one of those areas for the future.
Yeah, hi, Jeremy. Yeah, look, imagination is the inspiration of upcoming technologies. That's where a lot of these ideas have come from, a radical idea that someone thought was silly. Look, we're doing work in the area of mapping and overlays along with climates and weather predictions. These are all things that factor into your weeds and your seasonal growths, your biological controls. We were just recently down here in, I think, Helidon last weekend. There was a biological workshop which was about delivering biologicals in vegetable crops. Biological controls are the new future. So this is another efficient delivery system for that type of thing as well. And the mapping overlays to sort of to not so much preempt, but to at least map and control based on the data inputs of your identification of weeds in areas is certainly something that can lead into a further development in mapping and overlays, the same as we have our moisture and our soil profiles, our clay content profiles that we can utilise within our farm mapping systems. So there's a lot of watch this space, I suspect.
Thank you, Brock. Joe, I see you got
Absolutely.
your hand
And
up.
remember how I was talking about those different... Sorry.
No, I apologise, sorry.
Yeah, just a point of interest, what would be a rough cost for a setup on a quad?
Good question, Joe. What we've got there is what I would call an engineering prototype. So we've got to do a bit more work to commercialize it, like to have it fully commercial, but we're basically aiming for around about $5,000 a metre to be able to have the AI and spot spraying kind of capacity. So if you look at the standard weedits, which are the green on brown, the boom and the technology is roughly about $10,000 a metre. So we're trying to come under that kind of cost to give you a bit of an idea. So we work on a metre spacing, if that makes sense. So that's how we operate.
Yep. Very good. Thank you.
Okay, Jerome, if you'd like to close off our meeting for today, I will be circulating the significant information that has been passed through, as well as my introduction, which unfortunately wasn't working. But thank you very much for dialing in and for your time. We'll be sending through some correspondence.
Thank you very much, Lorinda, and thanks everyone for jumping on the call and spending your time with me. I hope you learned something and look forward to hearing what everyone gets up to.
Yeah, thanks, Jeremy.
Thanks, everyone.
Thank you.
Thank you. Thanks very much.